All right, Cadet. Welcome to your Starfleet Academy training simulation. Today, we're going to master a really fundamental JavaScript protocol for handling data. Pay attention.
Okay, here's your mission. You've got two data streams. Think of them as two separate arrays. You need to merge them. But here's the most critical part, the prime directive, if you will. You absolutely cannot corrupt the original data. So, how do you do it?
The answer, luckily, is in your standard issue toolkit. For an operation like this, we're going to deploy the concat function. This is the official, approved protocol for safely merging your data streams.
Let's pull up the technical manual. Okay, so it's a method used to merge arrays. Pretty simple, but I want you to laser focus on that second sentence. This method does not change the existing arrays, but instead returns a new array. Seriously, burn that into your brain. It is the absolute core of this entire mission.
So here's how you actually write it out. You take your first array, array1, and you call the .concat method right on it. Then, inside the parentheses, you just list out whatever else you want to add. Array2, array3, you can keep on going. But the most crucial part is on the left of that equal sign. You see that? You have to create a new variable, in this case, new array, to catch the result.
Let's see this thing in action. So we've got two crew manifests, class A and class B. We run class A.concat class B, and we make sure to save that result in a new variable, all students. And the output? Well, it's exactly what you'd hope for. One single new array with all the names in order. Super clean.
And check this out. Concat is actually pretty versatile. You're not just limited to merging two arrays. Here, we're taking the fruits array, tacking on the veggies array, and then we're even throwing in a single string, milk, for good measure. And it all just works, giving us one clean shopping list.
Okay, let's get to the single most important concept of this entire training. We call it the prime directive, immutability. This is a non-negotiable principle. You do not interfere with the original state of your data, period.
This is probably the best way to think about it, so listen up. Concat is like a photocopier. You know, if you have a report and need to add more pages, you don't staple them onto your original master copy, right? No way. You take the original, you make a fresh copy that includes the new pages, and you end up with a brand new document. Your original is still safe in the filing cabinet, completely untouched.
All right, I'm going to trigger a common simulation error. This is the mistake almost every rookie makes. They've got their prime numbers, they call .concat with more primes. I mean, it looks right, doesn't it? But there is a fatal flaw in this code. Can you spot what's wrong?
Okay, so we just ran that line of code. What do you think the value of the original prime numbers array is now? Did it get updated? Does it now include 7 and 11? Just think back to that photocopier analogy.
And let's check the simulation result. Look at that. The prime numbers array is completely unchanged. Now why? It's because the code worked. It actually created that new combined array, but we never told it what to do with it. We made a photocopy and just left it sitting on the machine. The original is safe, but our new work is gone. It's a classic silent failure.
So let's just break that photocopier idea down. First, the system identifies your source arrays. Then, concat goes to work making a copy of all their elements. And then, and this is the magic right here, step 4, it returns a completely new array. It's a totally separate thing in memory.
So, the correct protocol, the way to avoid that silent failure, is to always save the result. You have to capture what concat gives back to you. By writing const combined equals, we're telling the program, hey, take that new photocopy and file it under the name combined. Now we can actually use it.
Now, concat is the classic rock-solid tool that's been around forever. But, you know, Starfleet issues new field equipment all the time. So let's take a quick look at a more modern approach, the spread syntax.
Here they are, side by side. The concat way is very clear, very explicit. The spread way, with those 3 little dots, is just a bit more concise. What those dots are saying is basically, hey, take everything out of R1 and R2 and just spread them out inside this new array. The best part? Both of them get you the exact same result, and both are completely immutable.
So, which one should you use? Well, here's the tactical breakdown. Concat is amazing for readability. It literally shouts, I am merging arrays. But the spread syntax, well, it's popular for a reason. It's short, it's clean, it feels modern. For our purposes today, you can think of them as interchangeable.
All right, Cadet, simulation's almost over. Let's debrief the mission and lock in the key takeaways from today.
If you remember only one single thing from this entire training simulation, I want it to be this number, 0. That is the number of times the concat method will ever change your original arrays. It's 0, always.
So let's run through the final directives one last time. 1. Concat is for merging arrays. 2. It is immutable. It always respects the prime directive. 3. It creates and returns a brand new array. And 4, the big one, you must assign that new array to a variable if you ever want to use it.
Training simulation complete. I'm going to leave you with one final thought to take on your next assignment. You know how this works now, but I want you to start thinking about why it's so important. When is creating a brand new, unaltered copy of your data a massive strategic advantage over just changing the original? Think about it. Dismissed.